Hey everyone, John here, senior software engineer with 10 years of experience. I'm the lead maintainer of Latterly.io, the website in front of us, which is an open source educational and social networking platform to help you land your first or next programming role. Part of landing your next programming role will, particularly at the senior level, or particularly if you're going for big tech, will probably include Leetcode. Or more generally, whiteboard style coding rounds, DSA interview loops. These are basically all similar things. And so for that prep, we have the Leetcode kata, which is in front of us. There is the standard kata, which is a set of 12 problems using a spaced repetition-based learning style. And then there's an extended kata of 20 challenges once you get this first 12 down. And today I want to focus on course schedule. So course schedule recently came to a really nice answer that I like, but I have not gotten to the point where I have it memorized, basically. And the high level design is really straightforward and easy to remember, and that is you use BFS. Use BFS with topological sort, and the first step prior to running BFS, you need to merge the adjacency lists and then run BFS. So in terms of the high level abstract pattern, that's what to do. But in terms of the lower level syntax, we're going to see if I need to basically memorize it better. So we're going to see if I can remember this. So I'm going to review the solution quickly, and then I'm going to erase it, and then I'm going to try to rewrite it. Then if we have time, I will do a distractor problem and come back and rewrite the solution again. Erica says, I'm a computer science student. I'll earn my associates this summer. Congrats. Thanks for being here. The Bean, enjoy the day. I hope the work stuff went well today. So far, it's gone really well. Thanks for being here. Okay, so let's review it line by line. We have this solution that's under 40 lines, under 35 lines. And we are implementing can finish. The solution to can finish is basically run BFS. It's a single line solution which calls a helper, run BFS. Okay, so BFS takes all of the same arguments, self, num courses, and prerequisites. The first thing that we do is we rename prerequisites to edges list, and we do that to reinforce the statement, the identity statement, that the prerequisites are a list of edges. So we are going to treat them as a list of edges, and we are going to merge them into a merged adjacency list. We call it a merged adjacency list so that we don't create a false distinction. Because if we just called it adjacency list, that might create a false distinction that the edges list is not also an adjacency list. In fact, they are both adjacency lists, but one is a one-to-one list and the other is a one-to-many list. And both of those are adjacency lists. Thanks for the likes. Over 200 likes already. Appreciate it. If you're on TikTok, you can go to YouTube or Twitch. Link is in the bio and see the full screen. So once we have the merged adjacency list, the other thing that we need to do is we want to count the n degrees. So the n degrees is something that we care about with a directed graph. Is that right? This is where I'm going to start to get fuzzy. Let's Google the n degrees. N degree graph, n degree graph, n degree of a graph. So here's the degree in graph theory. I think it's just the count of edges, isn't it? The degree or valency is the number of edges. So you can have an in degree and an out degree. So the in degree is the number of vertices that are pointing to you. I guess it would be a directed graph then, wouldn't it? Because if they're pointing to you, in is a direction. So that should cue us that it's a directed graph. Okay. Because it's topological, it's directed. These are directed, right? A depends on B. There's a relational direction. Okay, so we're reinforcing this idea that there does need to be a directed graph. N degrees is the edges pointing to you. So the edge is pointing to you. That means you're a dependency for them. In this course schedule problem, if A points to B, it means that A depends on B as a course schedule prerequisite. Okay? So basically, I need to account for like how many dependencies does this course have? That's going to be my n degrees. Now what do we do with them? Now we're looping through the edges list. So here we're populating the merged. Here we're populating the merged list values. So to start with, we create this empty one. It's a list of lists. And then we are appending the blocked course. So if A depends on B, A is blocked. A is blocked and B is the prerequisite. And it's an adjacency list. It's an adjacency list. So we pick the index, and that's going, since merged AL is a list of lists, this will yield the dependency list for A, and we're going to append B. I was confusing because I said A and B, and blocked course is coming first, whatever. I said B because blocked. But this is the one who is the ooh, hold on. Is there a flaw here? Prereq course. So is this saying who do I block? Interesting. I need to get my head around better. This is a list of what? So course number 0 depends on course number 1, for example. Why is that not intuitive to me? That's not intuitive to me for some reason. So I have this adjacency list, and what is it going to be? I'm going to have the rows. I'm thinking I have a row for each node, right? So I'm thinking like course 0, 1, 2. Then I will declare the dependencies, like 0 depends on 1 and 2 in that row. And here, that's not what I'm doing. What I'm doing is I'm not saying, hey, for course 0, the dependencies are 1 and 2. I'm actually doing the reverse. I'm saying for course 0, you home? Yeah. Okay. What? It didn't come with a drink? No, she just handed me a bag. This is not intuitive to me for some reason. In the edges list, so this course is blocked by that course. This course is blocked by that course. That makes sense. This course blocks these other courses. This course blocks all of these other courses. Okay, so we're not just merging, but we're merging and flipping the direction. I think that's worth noting. So create merged AL from an edges list. merged AL has shows row in merged AL sublist in merged AL shows I guess the better way to say this is merge list sub I. Merge list sub I shows courses blocked by I. Is that true? Merge list sub I shows courses blocked by I. I think that's true. So in the edges list, the first index is who is blocked. And in merged AL, in the edges list, the first index is who is blocked. And in merged AL, the row is, it's also who is blocked, but it's who is blocked by the current row index. Yeah, this one's going to be hard to remember. I guess we're going to have to repeat this problem a bunch of times. Oh, well. All right, so this is like the hard part for me. Well, once you get this merged list, now you're making a queue and then it's BFS. And that's kind of like the easy part. Okay, great. So I'm going to make a queue and I'm going to loop through my nodes. You could call this V for vertex. You can call it whatever you want. We're looping through the nodes. And this is pretty intuitive to me. We're only going to loop through the nodes that have no incoming edges. Why do we do that? Because you can take that course. You can take that course. You can take a course if all your dependencies have been satisfied, and definitely all your dependencies have been satisfied if you don't have any dependencies, right? So the queue initialization for BFS is pretty straightforward. We create a topologically ordered list, which is a tricky concept, but at least initializing it is super easy. It's just an empty list. And then we loop through the queue. What do we do when we're looping through the queue? It's pretty just like autopilot BFS stuff. It's like you pop the first element of the queue. So every time you pop an element out of the queue, you put it into the top. You just blindly put it into the topological order result. Like it is topologically ordered because it's in the queue at this time. You don't really need to do additional analysis. Thanks to the sort of like beauty of BFS here, all of the work is being done to put the element into the queue properly. But once it's in the queue, you just pop it off and that is the topological sort. You don't need to verify that. You can just trust that. Okay, now let's get to the tricky bit about getting added to the queue. So once I have this merged AL, what am I doing? I'm getting DES. What is a DES? For each descendant. That kind of makes sense, actually. So you are a graph-wise descendant of A if you depend on A, right? So merged AL sub V is all of the courses that are blocked by V. All of the courses that are blocked by V can be characterized as descendants. So descendant here is just another word of saying blocked by. We can go to draw.io and just pull up a draw.io. Maybe not. What's the other one? Excalidraw. I always forget that word. Thanks for the follow. Excalidraw. So, right, you can just make like a graph. So here's A, B, C. So do we need some letters? So here's B, here's C. And here's A. You could say that A blocks B and C. Now, A is a course represented as an integer. It's a course represented as an integer in the vertex list. And so in my adjacency list, I'm going to look up A. A might have some integer equivalent, like A might be 3. So I'm going to look up row 3, and the value of row 3, it's going to be a list of other integers, which is just references to the other course IDs that are blocked by A. So I could say that those courses are blocked by A. I could also say that those courses are, from a graph perspective, looking at this graph, they are descendants of A. Does that all make sense? Cool. Shout out Excalidraw. We love to see it. So now that I'm computing a descendant, what do I do with it? So now I know that, hey, you're blocked by A, and I have you sort of in my hand in this current block. What are we going to do? The first thing we are going to do is we are going to decrement your degrees. I love it. Now, why are we decrementing your degrees? We're decrementing your degrees because this is the equivalent, like when I visit you, when I execute this line, it is the equivalent of saying V has been completed. Yeah, once we append V, this is equivalent to completing course V. It's equivalent to completing course V. That is why we are able to now decrement the dependency in degrees. Okay, so now that I have if it's 0, then I'm going to add it to my queue. That part, it makes tons of sense, doesn't it? I'm going to go ahead and submit this just so I have a record with my additional comments. So not much change here, just a couple extra, and we're right at 35 lines. Just a couple extra lines of code, which are comments, but I think they're useful. I think comments are extremely useful. All right, so I'm going to literally wipe this solution and immediately re-implement what I just wiped. Short-term memory. And so you build it into long-term memory by spaced repetition. If we have time, I'll do a distractor problem, come back and try to implement it again. Okay, so top of BFS, the only line of code that I want to keep here is this can finish, because this is the one that the system prompts you with, basically. And I'll keep that honorable mention comment. So let's read the problem. As if we're being given this problem again, there are a total of num courses that you have to take, labeled from 0 to num courses -1. You're given an array of prerequisites where the prerequisite of I is A, B. It indicates that you must take B if you want to take A sub I. You must take B if you want to take A sub I. So B can be called the blocker, A can be called the descendant, B can be called the dependency, the prerequisite. You must take B if you want to take A sub I. And notice that that is a one-to-one list of edges. So it's an edges list. We are going to return true if we can finish all of the courses, otherwise we'll return false. All right, and the examples are pretty straightforward. You know, there's a true case and a false case. The false case is equivalent to a cycle, is probably the interesting thing to note. That if you have 1, 0 depends on 0, 1, it's irreducibly complex, right? Irreducibly complex, it's a cycle. Okay, so strategy is BFS to produce a topologically sorted list if we if the list length is equal to the number of courses, then we can, then there's no cycle. If BFS completes with a list that's too short, we return false. In the worst case, we scan every node and every edge. So time complexity is O V plus E. The memory complexity is at least the number of nodes. I think it's the same though. I think it's also V plus E. Why would it be both? We have a list, a merged list, so we're going to need the complexity of the edges. And then the Q is the complexity of the courses. The memory complexity is also O V plus E because we will use a V-sized Q and an E-sized like other list structure. Python is the worst programming language. Is that why they call it the lazy man's programming lang? Maybe, I don't know. Madison, thanks for sharing. Question mark, thanks for the follow. Jacob says cycle check really, since return value is bool. Yeah, it is a cycle check. So we're going to be execute. So the problem, like, how do you do a cycle check? You could use DFS, and if there is a cycle, you will never terminate your execution, right? So that's one of the reasons that we like BFS here. Get up, please.
When's it going to be time to get up?
When's it time to get up? Not now.
But maybe in 5 minutes.
I think longer than that. Can you check with mom? I think probably 45 minutes, but I'm not sure. Okay, cool. So this is like the plan and the complexity analysis. Kev, thanks for the follow. So what are we going to do here? The first thing that we want to do, we just talked about the V-sized queue and the E-sized other list. Let's go ahead and do that. We want to merge the adjacency lists. Oh, well, I guess we just want to call BFS, self.bfs, and we'll make a BFS utility. Return self, and this is not an ordinary BFS, this is a topological. This is a topological BFS. Okay, so then we'll make a topological BFS. It will eventually return a topological list of completed courses. We're not going to return the list. We're going to return whether it's equal to the length of num courses. So this will be a bool. And for now, we'll initialize this to empty. Here, we're going to have a to-do, which is loop through BFS queue and add to queue. Let's put the and on its own line and add to queue if dependency count is now 0. Okay, so that's what we'll do after we initialize this queue. What do we do before we initialize this queue? We want to merge adjacency list. We want to init BFS queue. And I think we want to do one more thing. We want to calculate in degrees, i.e. dependency count. I think this is pretty much our steps. Jacob says, what's the difference in topological BFS from regular BFS? The difference is just the order. And in topological BFS, you're following a directed graph. That's pretty much the only difference. It's not a night and day difference. It's like if you're aware of it, it's a small difference. But also if you're not aware of it, you're like, why are we doing it this way? It's BFS along a directed graph. Okay, so I need to pass in my arguments, which is just all the arguments, num courses and prerequisites. Prerequisites. Did I spell this thing correctly? Num courses prerequisites. On the other side, we will call it num courses and flat edges list. Flat edges list, which is the one-to-one relations. And we are going to say that the merged adjacency list is equal to some function of the flat edges list. Jacob, thanks for the follow. Okay, and then Q is going, oh, we need to do the in degrees first because the in degrees will inform the Q. So the Q is element of merged adjacency list if element if length element is 0. I think that's right. The abstract idea is if you don't have any dependencies. If you don't have any dependencies, we can take that course right away. I'm not sure if that syntax is right. I think it might be this, L for L in the list, if, yeah, if L is 0. Oh, and we don't want it in here. We want here. So count, here we want the index, IDX for, is it items? We want the IDX for each list. We want the index if the length of that is 0. I think that's the right idea. I don't know if the syntax is right. Okay, so here let's make in degrees. And in degrees is going to be like 0. You just initialize it to 0 and then we'll tick it up as needed. 0 for L in flat edges list. Oh no, 0 for L in merged edges list. Good. It's reinforcing like, why do we need to define things in this order? We need to do the merged edges list first so we can compute the in degrees at the merged level, then the Q after, because we need those degrees to make the BFS Q. Jacob says, it's a cycle if the prereq is found in courses to be taken. Maybe. I might word that slightly differently. I'm not saying you're wrong. I'm just saying I would probably express that differently. It's a cycle if the prereq is found to be in courses to be taken and that prereq cannot be otherwise reached. That's the clause that I would add to make that a little more correct. But yeah, I think you're on the right track. Okay. Flat edges list. What is the, how do we merge these? We merge them with a for loop. We're going to do for flat edge in flat edges list. The value of a row in merged list shows blocked courses blocked by current row IDX. Call this merged AL. I think that's just a simpler way to say it. Merged AL is a list of blocked courses. Blocked by I. Merged AL is a list of courses blocked by I. Okay, so flat edge, the first index is the, here we're going back to the directions. A, you must take B if you want to take A. You must take B if you want to take A. So flat edges list 0, flat edges list 1. You must take B if you want to take A. So blocked is you, and prereq is you. You must take B if you want to take A. Therefore, A is blocked and B is the prereq. Cool, I think we got that right. That is so hard for me to remember. You must take B if you want to take A. It's just like a little out of order thing that just like explodes my brain. Okay. And the fact that B is for blocked, but it's not. That's the other, it's like a two, those are the two reasons that my brain is like rejecting the information. You must take B if you want to take A, except that A is the blocked one and B is the prereq. Okay. So what are we doing now? Now what we're doing is we are going to say that the merged adjacency list, and I want to look up the index here. So what's I? Is I A or B? The row is a list of courses blocked by I. So if you're blocked by I, then I must be B. You must be the prereq. You must be the prereq. And so this will be a list, and we will append blocked. I think I got through that correctly. Cool. Yeah, I think we're breaking through, y'all. I'll have to go through this like 2 or 3 more times to get it smoother. Like if this came up in an interview tomorrow, it would probably snipe me. I would be ruined. But if it comes up in an interview next week, we'll be good, huh? This merging is a pseudocode, so let's realize the merging. Here we can tell that we need a list of lists. So really, we just want a list for L in flat edges list. We're just initializing an empty list of lists. I think we're on the road, y'all. I think we're doing well. Now I just need to do the BFS. Okay. So for course in Q, we'll have okay, hold on. Something is wrong here. For course in Q, then I don't want to pop a course. What I want to do is I want to say while Q. That way I can evict my courses, and the eviction will self-terminate. K Vesterach from Twitch. Hey man, what's your rating in Leetcode? Pretty good question. Let's see. I don't know. Let's go see. I forget how to even see, to be honest with you. You can call me Nick, by the way. Much easier for both of us. Thanks, Nick. Good to see you here. Click on your profile. Okay. Oh, on the actual word. Okay. There's my ranking. I haven't attended a contest in a while, so that's why my score has been dropping. So that's me. Jacob says, if you map all prereqs in an object and then return check if any prereq at 0 is an object, return F. Do you want to try rephrasing that? It looked a bit like a word salad to me. Looked a bit like a word salad to me. Is there anything wrong with the approach that we've written down here? Okay, so while we have a queue, we want to potentially evict a course. So cur course is going to be queue.pop. And then what do I do with this thing? The first thing that I want to do is decrement the end degrees on the current course. The first thing I want to do is add it to this list. Jacob says, yes, I'm sorry, TikTok can only give me so many characters. Yeah, no stress, bro. I understand. TikTok, I understand the limitations. Trust me. Nick says, not bad. Nick, you're being too kind. It's okay. You can roast me. I do not try to paint myself as like a Leetcode top tier competitor. Leetcode is a tool I use for interview prep. I'm not going to be, like some of those guys. Yeah, so I could get the score higher if I care about it. I just don't care. I care about getting a job, I don't care what my score is. But thank you for the kind words anyway. So here, I don't want to say if. I want to say for descendant in depends on this course. So then the descendant, maybe we could just say child. That's one that's easy to spell and quick to spell, so I like that. So for child in depends on this course, we will reduce the end degrees of the child, and then if the reduced number is now 0, that's when we will add you to my BFS queue. Okay. And the wonderful, beautiful thing about this BFS is that you don't have to worry about the termination condition. Something about this is written incorrectly. The beautiful thing is supposed to be that BFS doesn't have a cycle problem. Like it cannot have a cycle problem, which is the one case where it's preferred to DFS. Usually DFS is going to be preferred. Because it's easier to write. Recursion is usually easier to write, and there's performance benefits a lot of the time, and there's lower memory overhead sometimes. But the way I've written this while loop, I'm not seeing my benefit. Oh, I think I am. So pop is going to mutate Q in place. I think that's the part that I'm missing. Pop is not just an index lookup. It's actually trimming Q. It's trimming Q every time. It's trimming Q every time. Something about this feels wrong, but whatever, we'll run it. We'll run it and we'll see if there's an error. Something about this feels wrong. Okay, so I have my current course. I add it to my topological list. Then depends on this course. This is a pseudocode. So what's the real thing here? How do I know what depends on this course? It is going to be the merged adjacency list. So I'm going to look up the current course in the merged adjacency list. And this will be for each child in that. We will run those. Let's go see where the error is. It takes 2 arguments, topological BFS, but 3 were given. 1, 2. Oh, I need to have self on the solution class. No problem. Merged AL is not a thing. Did you mean merged AL? Yes, you're right. List index out of range. Okay. Did not expect that. So this might not exist. I can just add a guard. That should be pretty straightforward. So if the length is 2. Object of type int has no length. Okay, this syntax is off. So what's wrong with this syntax? I'm going to submit this, and I'm not submitting it because it's right. I'm submitting it so that I can like store a backup basically, because Leetcode will save your submissions. I'm going to roll back to the previous solution, and I'm just going to look at this syntax right here. V for V in range num nodes is how they do it. Okay. If otherwise the same. Okay. So we're going to use range num nodes. If we're going on range num nodes, that means my other arrays are bugged as well, because they should be consistent. They should be consistent. So here, let me rewrite these. So this will be in degrees. The difference here is that this is going to be 0. And I don't need the if condition. Nick says, you solve the same problem so many times. Why? Spaced repetition to help with memory. So that when it comes up in an interview, I'm prepared for it. That's the reason. Nick, you can check out this Latterly Leetcode Kata blog article 3. And it will give you a whole lot more about why this is like a really good way to learn for coding interviews. Nick says, your graph can be disconnected. Try solving for each connected graph. That will make it cleaner. No, I want to solve for the disconnected case. That's on purpose. That's one of the benefits of BFS, is that it solves a disconnected graph, right? Jacob says, so are you doing an in-order BFS per day? Then checking if those are the same, you could explain your app. Bro, I am not understanding what you were saying. Can you explain your approach? Yeah, I think I did that I don't know if you were on the video when I did this. By the way, the stream is saved. So if you missed some of it, you can go over to YouTube and look at the live recordings. But basically, we're going to do a BFS to produce a topologically sorted list. And then we're going to check if that list length is equal to num courses. And if they're the same list length, that means we were able to complete all courses. Does that make sense? If it's too short, that means that some of the courses, when we iterated through them, we could not satisfy the requirements. And so you'll have an undersized list, and you'll end up returning false on this final expression down here. So I was doing something over here. We fixed the range statement on the queue. We fixed the range statement here, and wanted to fix this merged AL1. Okay, that's what I didn't finish. Cool. Num nodes is not defined. Oh, I have num courses. All right. So the int is not iterable. That's not good. This is not supposed to be an int. It's supposed to be a list. Okay, let's look at the solution. So here's the one, like a really good solution on the left over here. So looking into the for each descendant in the merged adjacency list, for in I never incremented my n degrees, did I? So the adjacency list of oh yeah, this is bad. Maybe not. The list index is out of range. I'm surprised that this is out of range. Why is this out of range? Is this a Leetcode hard? No, I think it's a medium. I mean, a lot of the mediums are difficult until you like basically get the pattern down, and then they're pretty much easy. With a lot of the hards, it's like even if you know what to do, it's just still hard to do it in the timeline. Okay, now I know why I'm super dumb. This should be flat edge, not flat edges list. Okay. Int object has no attribute append. That's true. Merged AL is V for V. That should be an empty list. Much, much better. Okay, so now we are all the way down here. Right. and I did the reciprocal comparison. Cool. Okay. So the solution here is wrong, but no error. So why is the solution here wrong? We are somehow getting to the case where number of courses is equal to the length. Yeah, so we're not incrementing the n degrees. So here, n degrees plus equals 1. The n degrees of who? Is it the blocked or the prereq? N degrees means that given a node, these are the people pointing to me. They are depending on me. So I am the blocker. So I'm the prereq. You see that those logical steps that I just did? That's what people mean when they say like the abstract understanding. I thought you worked at a startup. Over as of June. Over as of June. I did last month. Layoff's gonna lay off. Okay, so that worked. Why did this not work? Yeah, I expect this should work. Let me print n degrees down here. So it printed 1, 0. This is number 207, course schedule. Thanks for the question. I think I'm running out of time, so I think I might just throw this into ChatGPT. I'll give it 5 more minutes. So here the n degrees, something is wrong with my n degrees. 0 for v in range. I'm expecting this is a flat list. Why is it looking like a list of lists? Oh, okay, that's the input argument. This is the standard out. Right, so n degrees is a flat list. Okay, that is what I expect. The 0 course has a dependency. Good. So it never got decremented. It never got decremented. That's the problem. Why? Yeah, it could be my while Q. Let's go see. It is while Q over here. Q pop 0, that shouldn't mean anything. Count plus 1, the count is irrelevant. All right, let's see. Let's ask ChatGPT. The line in degrees should update the in degrees of the blocked, not the prereq course. Wow, I'm dumb for 2 different reasons. That's cool. No, I disagree with the third one. Also, I disagree with the second one too. Yeah, you can pop it in either direction. That's what she said. Okay, so really the problem is my in degrees. Let me think about that. I'm not saying that it's wrong, and we can easily just test it and see. So let's go ahead and test it, I guess. Great. But why? Why? So here, I am blocked by all of those people. My in degrees is the count of those people. I am blocked by all of those people. I hate that so much. It makes so much sense now. Why did that not make sense a minute ago? Brains are weird, yo. Like, I thought it made sense the other way. And then now that I like reread it, it makes sense this way. So this would be like the out degrees, like y'all depend on me. That would be the out degrees. This is I depend on all of you. I depend on all of you. Cool. Only one issue you would have leaned towards for higher. What does it mean? Only one issue you would have leaned towards for higher. Oh, are you saying like, okay, are you saying like if you graded me, you would have leaned towards for higher? That's really nice. That's really nice. All right, well with that, let's in degree is wrong, should be blocked. Okay, thanks Twitch. Yeah, you're right. I just saw your comment now, but you're right. JCast19 on Twitch. Thank you so much. Everyone, thank you for being here. Wonderful to speak with you. That's a wrap for today. I hope you'll visit around the same time tomorrow. We'll be doing some more Leetcode.